Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to explain you about how bottom-up parsing is working with various different parser. Usually bottom-up parser attempts to construct a parse tree by reducing the input string, and it almost uses the rightmost derivation to do that, right? So I have an example here. The first parsing technique we are going to see is shift reduce parsing, right? So this is a given grammar. You can check the grammar here. East tends to e plus e, east tends to e asterisk e, east tends to open bracket e close bracket, east tends to id. So here you can see all the terminal and non-terminal terms in this particular given grammar, right? So the example has been given with the input string matching, that is id1 plus id2 asterisk id3, right? So what is the first step we are going to do here? It is we are going to take leftmost derivation for the given particular grammar. So in this particular grammar you can take any of the production rule and to derive that with the rightmost derivation part. So I have taken the first production rule, e tends to e plus e, right? Now you can see this, I have taken this e tends to e plus e. The part here we are going to perform is rightmost derivation. I am going to take the last non-terminal term in this particular production rule. The last non-terminal term is e. I am going to take this. From this I am going to right to left. So rightmost derivation starts with the right part of the non-terminal, that is the last non-terminal in the given particular production rule. So I am going to traverse in this particular way, right? So I am going to reduce this. What is the possible way we can expand this or reduce this e? So we can check it. This e we need to match this particular production rule. So I have taken this e to match id1 plus id2 asterisk id3, right? Let me tell you. So here this e can be expanded into e asterisk e. I will show you this particular example how this e has been expanded. You can see here. This e has been expanded into e asterisk e. So in order to match this particular input string, right? So e plus this e has been expanded into e asterisk e, right? So there is no more expansion is needed because almost all the e can be reduced into id. So I am stopping here. So now I am going to retake this particular right hand. This is the rightmost derivation. So I am starting from this e. Now this e can be reduced into id. How does it happen? So exactly in this given grammar you can check it. This e can be reduced into id. So here e plus e, this e has been reduced into id. So I am giving that as a number 3, right? So the next most important thing is next non-terminal which is applicable after this, that is capital E. This E is again reduced into ID. So I have given that as ID number 2. So finally, almost all the non-terminal has been reduced. The only one part is here. That is the last part of this particular given expansion of production rule. So this E again reduced into ID. So this ID1, ID2, ID3. This is the finest part of this particular production rule. And we have exactly matching this with the given input string, right? So let me take you to the second step to perform a shift reduce parsing. Here you can see the second step, that is we need to have a stack, the input symbol, and then the action. Whatever the performance, that is shifting or reducing, we need to mention an action, right? The input is already given with the example, that is id plus id and asterisk id. Now the stack it will be starting with the dollar symbol, and also input is ending with the dollar symbol. So dollar and dollar matches, or else starting and dollar matches, start symbol or dollar matches, then we can conclude that we have reached the top part of it. That is, we are finding the uppermost root of it, right? So let us shift and reduce the thing. So I'm going to shift all the inputs from input to stack, and then I am going to check whether there is a possibility of reducing it, right? The first thing is I am going to shift this id. So id has been shifted here. One by one we need to shift. id is a terminal term, plus is also a terminal term. Both together we cannot shift it, right? This is the first part. So id has been shifted into stack. Now we need to check for the possibility whether this id can be reduced into e. Yes, there is a possibility. So e tends to id. That means we have a production rule, that is id can be reduced into e. So I have reduced that id into e. You can check it. So whatever the performance or whatever the action you are doing, we need to mention here. First, initially we shifted. Second thing, we have reduced this id into e. So there is a e here, right? So what is the second possible thing? We need to move this plus here, right? That is the second possible thing. So plus has been moved here. That is the second thing. So I am shifting plus. Again I'm moving this id, so I'm moving this id here, right? E plus id. With this e plus id we cannot do anything, so we are looking for the reduction part. So you all, as you all know, this id can be reduced into e. So here after reduction e plus e will be there, right? So now I'm going to reduce this particular thing, because before moving anything from the input symbol we need to reduce the stack, or else altogether we cannot reduce. So we need to reduce the maximum possibility here. Let us check whether we have a production rule to reduce this. Yes, there is. We have a production rule called e tends to e plus e, which can be replaced. This e plus e can be replaced into e. So this is the possible reduction, right? After reducing this we are moving the star. After star we are moving this id. Yes, here it is. So after id, this id can be replaced into e, as you all know that how it happens. Now what is the finest part where we can reduce this? Yes, we can reduce this. That is e tends to e asterisk e. So here you can see e tends to e asterisk e. So e asterisk e can be reduced into e. You can check it over here. Now we can able to see that this is the last part we can able to reduce. So furthermore, we cannot reduce any of this particular non-terminal into any other non-terminal. So in the given grammar, you can check it. It will be starting from e tends to e plus e. So e is the starting state and this is the stack here, and it should match at the dollar. Dollar is the last symbol which is available in this particular input. So the starting symbol and the root node is dollar. So if this particular path arrive, then we need to say that this symbol as exactly matching and shift reduce has been performed and parsing has been done its part successfully. Thank you.